You start with the best intentions, saving kitchen scraps, raking leaves, waiting for rich, dark soil. But instead of earthy compost, you end up staring at a slimy, foul-smelling mass, or a pile of dry, mummified scraps that look exactly like they did 6 months ago. It's easy to assume you lack a green thumb or added the wrong ratio of ingredients. Organic matter naturally breaks down. When that process stalls, the physical environment has shifted out of alignment. The common reason a pile slows down is we treat it like a static garbage can. A compost pile is actually a living, breathing biological system with strict physiological needs. Managing a pile requires structural engineering. You must maintain the habitat that keeps a microscopic workforce alive. The first major failure is the water trap. Composting requires moisture, but there is a strict biological limit. Once the moisture level in your pile crosses the 65% threshold, active decay stops and the stench begins. Microscopically, compost has tiny pore spaces holding air. Above 65% moisture, water floods these gaps, displacing oxygen. Aerobic microbes suffocate, and anaerobic bacteria take over. Thriving without oxygen, they feed and release a pungent ammonia odor. Excess water also triggers a second physical consequence. It acts as a massive thermodynamic drain. This chart shows bacterial community compositions from a study on sewage sludge composting under varying moisture contents. Notice the consistent color bands across piles A, B, and C. High moisture doesn't wipe out the microbial population. It simply makes the pile too heavy to heat up. Water has a high specific heat capacity, taking massive energy to raise its temperature. Bacteria cannot generate enough metabolic heat to warm a waterlogged pile. Wet kitchen scraps create an impenetrable thermal shield, effectively freezing the decomposition process in place. That brings us to the second system failure: green suffocation. A common habit is overloading the pile with fresh, nitrogen-rich greens like grass clippings and heavy food waste. Fresh greens are excellent biological fuel, but possess high bulk density. Heavy and wet, they lack internal structure and collapse under their own weight. Without rigid brown materials to prop the pile open, compression seals off internal pathways. Airflow stops entirely, suffocating the system. On the opposite end of the spectrum is the third failure: hibernation. If your pile dries out and the moisture content drops below 40%, the microbes don't die. They simply go dormant, waiting for water. The fourth failure comes down to scale. Small compost piles, or those tiny plastic countertop tumblers, bleed away thermal energy much faster than the microbes can generate it. Active, hot composting requires a critical mass. In general, you need a minimum volume of 3 feet by 3 feet by 3 feet to provide enough mass to trap the heat generated in the core. Structural density and overall volume are the physical controls of the system. They determine whether your compost breathes and holds heat, or whether it suffocates and freezes. If your compost is stalled, it can be salvaged. The biology is waiting for physical adjustments. For a wet, smelly, anaerobic pile, the fix is introducing structure. Mix in bulky, dry brown materials like autumn leaves or wood chips. These absorb the excess water and physically prop open the pore spaces for oxygen. If your pile is dry and dormant, add water. Mix the material until it feels exactly like a wrung-out sponge to wake up the microbes and restart their metabolism. And if your pile is cold and stalled, you have a volume problem. To reach active decomposition temperatures, you must consolidate your materials to build up enough mass to trap the heat. These simple physical adjustments correct the airflow, the moisture balance, and the thermal insulation. Success depends on maintaining these physical conditions rather than following a magical recipe of scraps. Providing the right physical environment allows nature's microscopic workforce to do the actual work of creating soil for you.